Okay, so this month, and I don't know why, they started in the middle of the month. So it's like from September 16th through October 15th, we have Hispanic Heritage Month. And so I am going to do a little presentation on several astronauts who are Hispanic and have broken barriers because we all know that there's not much diversity in the field of science. So I want to share this video just to give you an idea of science is available to all of us, and these people have been able to kind of overcome the odds.
As a touch and go landing on an asteroid, the OSIRIS-REx spacecraft successfully landed on the surface of an asteroid as tall as the Empire State Building, spinning like a top. The craft collected a sample in about 5 to 10 seconds and is now heading back more than 200 million miles to Earth, arriving here in 2023. The aim of the mission is to provide more information about our solar system and see how we can prevent an asteroid like it from hitting our planet. And from an asteroid in outer space, we bring you back here, the glimpse of the future. The push will attract more young Latinos into the fields of science, technology, engineering, and math, where they are largely underrepresented. ABC's Marcia Gonzalez with more on this mission.
You feel the general vibrations of the three engines coming to life, and then the two solid rocket boosters about a second later turn on. Now the noise level goes up in order of magnitude, and the vibrations become more violent, like a big earthquake. Now, when you think the whole thing's gonna fall apart, you blast off.
It is an unparalleled thrill and an accomplishment few other Latinos have achieved. Jose Hernandez, a first-generation Mexican-American.
We were hand in hand with my parents out there picking the fruits and vegetables to help with family income.
Going from farm worker to astronaut. Inspired as a 10-year-old boy watching the Apollo 17 moon landing.
And then I was hooked.
It's gotta be one of the most proud moments of my life. I didn't see it.
I said, that's what I want to be when I grow up.
And now inspiring other young Latinos to follow in his footsteps. The Latinos make up nearly 20% of this country. Only 7% of the science, technology, engineering, and math workforce is Latino. Organizations like HOLA, the Hispanic Outreach Leadership Alliance, are working to change that.
STEM careers are the way of the future, and in order to be competitive and build a diverse future STEM workforce, young people need to see that it's possible and that these jobs are for them too.
A part of spreading that message is sharing stories of others in STEM fields, like engineer Bear Walker Hannon.
I'm a big believer in the term representation matters. It is important to educate Black and Brown students in the STEM fields.
And Ellen Ochoa, the first Hispanic woman to go to space and now the chair of the National Science Board, who faced countless challenges.
I did run into people who tried to discourage me. It was clear that I just didn't fit their picture of who becomes an engineer or a scientist.
Ochoa is now changing that picture and charting a path for the next generation of Latinos in STEM fields, like high school junior India Carranza.
She's an inspiration. She advocates for fair opportunities for all women in STEM field. Each day she inspires me to reach for the stars, just like she said.
Now seeing their own potential in the faces of these trailblazers.
When I have the chance to reach out to young Latinas and talk about STEM fields, so the first thing I want to say is we need you. We need your minds. We need your creativity, your way of looking at the world, your welfare of your loved ones and your communities. And those are all things that will be really important for both succeeding in STEM and helping us solve problems.
Marcia Gonzalez, ABC News, Los Angeles.
Okay, what I want to do to save time, because I do think working on worksheet 4 is valuable, especially if we have a test coming up. But what I would like to do is, instead of having everyone collect data were any of my groups. Pull out your blue worksheet. And I want you to raise your hand if any of my groups were able to collect any sort of acceleration along with their force value. So I did have a few. Okay, so what I'm going to do, were there any groups that didn't get any values for acceleration? Okay, so I think that was group 7A. Group 2, you didn't get any acceleration? Oh, you did? Okay, good. Okay, so here's what I'm going to have you do. Some of the groups that did not get values, I'm going to have you reflect on the values that the rest of the class got, and we're going to develop a mathematical model together as a class. Because as you know, the more data we have, the better our results. So here's the data that I collected. And for those of you sitting in your groups, my tech managers, I want you to pay attention closely. Under our, sorry, let me refresh this because this is something I added last minute. Under our agenda for today, there is a link to enter data. And I entered the data that I collected just through my own trial within the class. So what you're gonna do, and I know it's gonna be hard because you're all typing into the same document, find a spot within this document where you can enter your group's data, and then it should automatically populate our graph, and we're going to analyze this mathematical model up here together. So, can I have you guys come back to your seats? Because I want to do a clear lesson on the results from this lab. A very, very clear lesson. This is going to help you with worksheet 4. Did you guys finish group 2? Okay. So, this is everyone's data. This is everyone's data from our class. We have about 22 pieces of data, probably 21, because we have a title there. So with 21 pieces of data, let's look at our mathematical model here. So first of all, I'm going to print this out for everybody. But let's turn this. So if you turn to the back of your paper, it says log or pro. We'll make a graph of force versus acceleration. Write a mathematical model below. So let's just start with the mathematical model first. And this kind of gives you a different setup, but it actually writes it out. It writes it out as an equation for you. So I want to show you something. Y equals mx plus b. Force is already plugged in for your y. So force is your y. Your m is written out as 0.531. What are we going to plug in for x? Is it x? Homer. Acceleration is our x variable. And then you've got this y-intercept. So the y-intercept is 5.38 e to the negative 3. What does that mean exactly? So 5.38, that e to the negative 3 is, what is it, Tomer?
It's 10 places lower.
It's 10 to the negative 3rd power. So what does that mean? I'm going to take this decimal and move it 1, 2, 3 spaces to the left. And look at this y-intercept. It's 0.00538. Pretty freaking small. Don't assume it passes the 5% rule. I want you to do the 5% rule to check it. Okay, we've got a lot of data here. And we need the max force. So let's see, what is our max force? to get our information. It looks like it's about 0.3 something. Oh no, we've got a 0.4. 0.426 is our max Y value. So I'm gonna have someone come up here. Let me get a volunteer. And I would like my mathematical model written up here, along with the 5% rule. Can I get a volunteer to also do the 5% rule with the mathematical model? All right, let me have Leo. All right, everyone, we didn't do experiment 3 yet, but everyone got their graph, right? I want you to attach this graph onto your worksheet. And we're going to write out the mathematical model. We're going to start with what Leo has come up with and see if we agree. First of all, we already established y equals mx plus b. We need the variable, force, and acceleration for the y and the x variable. Very important. If you miss it on a test, you're going to lose points. Then we need the unit and the y-intercept. Now, Leo didn't do this first step, but usually on your test, I'm going to have you write out the whole mathematical model first, do the 5% rule after, and then write out the final equation. So before we establish that we drop the y-intercept, we're going to plug it in. It's 0.00538. Okay. What else do I need to make this equation perfect? Leah. What is my unit for slope here? Kilograms. So my unit for slope is going to be, and I want to work this through because is it Sophia? Sarah. I knew it started with an S. So we want to make sure that we have the right unit. Sarah came up with kilograms, but let's see how she figured that out. So first, we have rise over run. So our unit really is newtons. Newtons over newtons divided by kilograms. It's a fraction over a fraction. That's like mind-boggling. Jehu.
Well, what I'm curious about is why is the force the independent variable?
Really, really good question. Usually, your dependent variable is your x variable. And the only reason why, and I emphasize to do this on the back of the worksheet, the only reason why I changed it is because our slope is going to give us a really important value, but only if we do it in this scenario. So this leads us back to Sarah's unit. Tomer, did you have the same question? Something different? Okay, so Sarah said that this unit reduces down to kilograms. Let's look at it. Anytime we have a fraction over a fraction, we always want to multiply by the reciprocal. Remember that from math? So we get newtons over 1. I turn it into a fraction. I multiply it by kilograms over newtons because that's the reciprocal. And then we cancel it, the newtons out. It ends up that this turns into kilograms. Now, Jehu had a good question. If I flip this around, and I had the newtons per kilogram over kilograms, it would end up with a funky equation. I would end up with newtons over kilograms squared, which we don't really know what that unit represents, but what we do know is what kilogram represents. What does kilogram represent to us? Tomer? Okay, Leo? Mass. This represents mass, and that's the value that we're trying to get out of this scenario. Tomer, question.
Newtons over kilograms, and then it's times acceleration, right? Again. So acceleration is newtons over kilograms. So can you just wipe all that out and then it's just newtons on top?
Well, it is newtons on top, and guess what? Once you solve it, you get a force in newtons. So that's exactly why you want to kind of cancel everything out. Okay, the other thing I wanted to talk about is if we decided that the unit is kilograms and that this represents mass, how many of you guys were able to measure the mass of this fan cart? Were any groups able to measure it? What did you guys get for that value? 0.537. Holy. 0.537 kilograms. Look at what we have here. You can't see it. Sorry, guys. So we've got a actual mass of 0.537. We're going to take group 8? We're going to take group 7's word for it. And then we have our experimental mass. And our experimental mass was 0.531. Pretty darn close, right? So here is our final equation. Oh, before I start, I still need to include the unit for y. You are going to lose points if you don't do that. So what's my unit for y here, Bennett? Not force over, oh, sorry, you said the force of newtons. So we only want to put newtons, only include the unit, but it is a force. And then we realized here, just as Leo said, we drop it because it is 1.3%, and we want to make sure we drop anything less than 5. So here is Newton's second law. Newton's second law states that force equals mass times acceleration. F equals ma. This is second law. I'm writing it here just so that people can see. We just developed Newton's second law in our class. Pretty cool, right? Okay, you're going to use this in your equations. But before we start, I'm not going to have you do experiment 3, but what I want you to understand is the concept of instead of changing the force, what would happen if I changed the mass? So we've got an acceleration. I'm going to turn this on its max speed. Max speed. That's its acceleration. I've got these masses here. What is going to happen to the acceleration? And we're not going to measure it, but we're just going to observe. What's going to happen to acceleration if I add more weight and more mass to this? Max.
It's gonna decrease.
It's going to decrease. You guys have experienced this, right? When you are trying to drive a small car, it goes pretty fast. When you try to drive a heavy car or a truck that has a lot of camping gear, I just went camping, so I just experienced how hard it is to accelerate a heavy object. So I'm going to turn this, I'm going to put max mass on here. I'm going to turn it on max speed, and let's observe the acceleration now. Pretty darn slow. Come on! It's not even strong enough. So, in conclusion, the back of your worksheet, what does it say? In the back of your worksheet, I want you to, we're not going to fill out all of this. All I want you to write down is the concept that as mass increases, what is the effect of varying mass when the force remains the same? We'll say as mass increases, acceleration what? Can you guys see? Sorry. Acceleration decreases. You're going to want to know the terms for this. Tomer.
I just had a random question pop up in my mind.
Yeah.
Like, as if for every blah 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 force, the acceleration goes up by that much.
You guys want to do the for every statement together? Okay, let's finish off with mass acceleration. The first thing is this is what we call an inverse proportion. And the symbol I use for proportion is like this little fishy symbol. It shows that mass is proportional to the inverse of acceleration. M and A, you want to know how to use those variables. As one goes up, the other goes down. This is what the graph looks like. It's not linear, it's decreasing. Just like this. This is your inverse proportion graph. Question, yes. Is it what? Oh gosh. Is it? I think it's alpha, no? It's alpha. Yeah. Okay, so they're inversely proportional. That's what the graph looks like. Anything that's directly proportional is an increasing graph. So what you have here on your graph, and you can write it down, is a direct proportion. As force increases, or sorry, you can use them interchangeably, but as force increases, so does acceleration. And your graph is obviously linear. It increases in a straight line. Okay, let's go back to Tomer's question about for every statements. For every statements always start with our denominator. So if you look at the slope, our denominator, oh, we don't have a denominator. Oh, sorry. It starts with our acceleration. Tomer.
That's what I was thinking, but it just didn't make sense to me because it seems like acceleration would depend on force. You're
right. Yeah, no. So generally, we would have graphed it different. The problem is we wouldn't have gotten this nice value of mass. And so we're going to write it for every statement based on the kind of graph that we created. So even though it's not technically the way we had run the experiment, we're going to do it that way. So in this scenario, we're going to say for every, and you're going to write this on your worksheet, not on the lab. There's a section for the for every statement. Let me write it over here. And let's just write what our slope is. It's 0.531 kilograms. So it's going to say for every 1 Newton per kilogram of acceleration, our force increases by our slope, 0.531 newtons, not kilograms, but newtons. So what I want to explain to you is acceleration, when we get into kinematics, is going to be represented by meters per second squared. But because we haven't talked about that yet, we're going to leave it as newtons per kilogram for this unit only. Any questions on this lab? All right. Let's get into worksheet 4. Worksheet 4 is everything we've been doing, force body diagrams, solving equations, except for this time, you guys are going to have unbalanced forces, meaning that not everything is going to be equal, okay? So, in order to solve worksheet 4, this is in your packet, I want you to use something called the guess method. How many of you use guess method in math? Nobody? Okay. Generally, when I was a math teacher, I would use this in math. And what I would do is I would have students write out the givens. What's given to you? Sometimes it's mass. Sometimes it's the force of gravity. The force of Earth on the object. Sometimes maybe it's the applied force on the object. Write down all the different information that's given to you, including the sign. Then you're going to write what you're solving for. What force is it asking you to solve? And then you're going to write down your equation. The equations we have are the sum of the forces on X, the sum of the forces on Y, and the force, we now have 3. Force of Earth, the gravity equation, and F equals ma. Those are our 4 equations we have so far. You're not going to lose points, but these problems, because we have more equations and moving objects, it is going to be really helpful. And then substitute and solve. So you want to find, based on your givens and unknowns, you want to figure out what equation has those values and how you can solve for it. The next thing I want to highlight is drawing a force body diagram, whether it's balanced or unbalanced, is important. And a lot of you don't realize that you can solve for the frictional force because they gave you the applied force. So here's a tip. Write it in your force body diagram. If, for example, I tell you that mass is 100 kilograms, and I ask you to solve for the normal force, then I can solve for my force of Earth here, right? Negative 9.8 times 100. So I get 980 newtons in the negative direction. And I can easily see from my force body diagram that this should be what?
Positive 980.
Positive 980 newtons. I don't even have to solve it, although you do in your worksheet and you do in your test. But it's easier to see it visually, at least for visual learners, if you put your values in the force body diagram, and you also remember that you have to include the sign. So if you see on your diagram that it points left, then you include the negative. Tomer. You can do it off to the side. Yeah. So some of the worksheets don't ask you to draw a force body diagram. And again, I'm not requiring to use the given method, but I highly encourage it because these problems, now that you have 4 equations to use, are going to be valuable. It's going to be hard to figure out what you can solve for. So let me have you work on your groups. For the remainder of the period, I want you to finish up this worksheet. I want to save some time to do a little whiteboarding on some of the harder problems. And then your homework tonight is to start review worksheet and to hopefully you get this done in class, but to finish this if you don't.